clean and burning bright. Biofuel, you can cook with it at night. Biofuel, make your diesel right. Biofuel, you can drink it if you like. All around the Southland to the farmer's sweet delight. They're gonna burn in bio, everything's gonna be alright. Up from filling stations, their slogan was for sale. Buy our fuel, it's biofuel, let's breathe cleaner air.
Biofuels are hydrocarbons made by living organisms that we can use for fuel. Biofuels are the original fuels used by humans in the form of plant matter burned for cooking, heat, and shelter. Greater than 95% of the energy consumed in transportation are the fossilized remains of bio-originated fuels. Biofuels can be subdivided into three categories: biomass, biowaste, and biofuels. Biomass is an energy source that is most often stored in the chemical bonds within cellulose molecules in plants. Wood and other dried plant materials are the most common. Biomass annual production has been estimated at 146 billion tons per year. The vast majority of this biomass is in the form of wild plant growth. Agricultural production of biomass could range from 20 to 50 metric tons per acre. These fuels are usually directly converted to heat energy through burning. The burning does not have a net impact on atmospheric carbon dioxide, as the carbon contained within the fuel is a direct result of bonding atmospheric CO2 through photosynthesis. The burning of biomass does result in airborne pollutants such as carbon monoxide, volatile organic compounds, and nitric oxide. Biomass can be further refined through either chemical degradation or biological digestion. Chemical degradation through heat and chemicals can take energy stored within the cellulose molecule and convert it into molecules that can be directly used as fuels, or change the cellulose into a molecule that can be more easily used in biological digestion. Very few organisms can digest cellulose into usable fuel source. Though there is currently research into anaerobic bacteria that can digest plant cellulose into usable glucose, hydrogen, lactic acid, and acetate for biofuel production. Biomass can also be stored in plants in the form of starches or sugars. These starches can much more easily be processed into usable forms of fuels. The starches can be converted into simple sugars through enzymatic reactions, then biologically digested into usable ethanol. This ethanol does need some further refining through distillation before it can be directly used in modern internal combustion engines. This ethanol comes from two primary sources: corn in the United States and sugarcane in more tropical climates such as Brazil. Corn yields less ethanol per acre than does sugarcane, and its refining requires more heat energy input. The advantages of biofuels lie in that they can be readily used within our existing infrastructure of petroleum distribution with little to no modification. They can also be directly used in most modern internal combustion engines in varying concentrations, with some newer cars being able to use upwards of 85% corn ethanol fuels. These fuels are in a sense carbon neutral, though their production and distribution may not be. Systems could be developed and implemented to achieve carbon neutral biofuel industry. There is also a potential for energy independence in biofuels. But this can come with an ethical dilemma. You have to ask how we can be diverting food products that could go to stopping global hunger into domestic fuel and energy programs. The current benefits of domestic corn ethanol production could just as well be achieved with stricter fuel efficiency standards. Corn ethanol production is what has been implemented due to its ease of adoption in a grab for billions of dollars in federal subsidies and tax credits. A more sustainable approach to biofuel production would need to come from a cellulose solution as to not be pushing food prices higher, contributing to global food shortages in the poorer countries of the world. The environmental impacts of industrial-level corn ethanol production could include groundwater depletion, pollution from irrigation runoff, pesticides and herbicides, and other agricultural problems associated with monocultures and genetically modified food crops. Domestic corn ethanol production relies on a subsidy of 45 cents per gallon, as well as taxes on imported oil in an effort to stay economically competitive, as well as a government mandate that gasoline contain 10% ethanol. This subsidy expired in 2011, though the government mandate remains in place.
The future of biofuel is bright. With near-record oil prices, the future of biofuel has seen interest nationally. Global biofuel production has tripled from 4.8 billion gallons in 2000 to about 16 billion in 2007, but only accounts for less than 3% of global transportation fuel supply. 90% of production is concentrated in the US, Brazil, and European Union. What's this mean? Well, this means that production could become more dispersed if development programs in other countries, like China, are successful in making biofuels. Basically, this means they could generate more money. More money, the better. Why is this better? Well, this means we're using more. The more we're using, the better it is. Some people might disagree with that. Those people that clean up the planet, go green, recycle all that. Technically, that's what biofuels are doing. We're turning waste into energy. So, for those people who believe in help cleaning up the planet, biofuel is doing that. The future is cleaning up the planet. And as those people say, go green! Biofuels are big to Idaho. Biodiesel are the biggest of the biofuels that are in Idaho. The reason they're the biggest is that interest and demand are really high. This just shows that Idaho is trying to focus more on using biodiesel rather than regular diesel. An estimated 40% of our diesel fuel could be grown and made within the state of Idaho. This growth of biodiesel use shows that one day in Idaho, biodiesel could be a viable industry, let alone the rest of the United States. Although Idaho has the second highest per capita diesel rate in the U.S., it would be called what people call diesel short. This means they cannot meet the growing needs of biodiesel. Other minor examples of biofuels in Idaho would be oil and wheat crops. In 2007, Diversity Fuels announced its plan to build the largest oilseed processing plant in the Northwest, which will be capable of producing more than 40 million gallons of food-grade oil annually.
Knowing what I know now about biofuels, I believe I know enough knowledge to help ensure a more sustainable energy future for our community and the world as a whole. The first step I would recommend is stick away from using food or crops as the main source of creating the energy. But how about rather find a new way as using non-food items? It's something that has been barely talked about, and yet if we just hit the nail on it, can emerge as something so much greater. Because we would clean up the earth while using it, and yet we're creating energy for ourselves, which is a win-win. And it would be sustainable because it's the excess garbage that we have from our food. We don't have to do anything extra from it. It's just something that we're given from our daily needs. And a way to sustain it is just to be smart.
Biofuel, biofuel, make your diesel right. Biofuel, biofuel, you can drink it if you like. A man in a white suit fills your tank with a smile and a care. Says, fill your tank without a fear, and you're off the map now, safe you here. Learn the soil, get around from over here to there. Next time that you see him, you'll breathe cleaner air.